This is Johnny Kunkel, and in this video we're going to revisit some of the database design and look at the logical design in a little bit more detail, and we will be transitioning into physical design. With what we learned previously, we learned about functional dependency and that this is used to maintain the quality of data in the database, and that for whatever is on the left side, there is only one value for whatever the attribute is on the right side. We also learned about the rules that we use for normalization to eliminate redundancy and anomalies to give us a good database design. And this is where we process through first normal form to remove any repeating groups, then through second normal form to eliminate partial key dependencies, and to third normal form, which voice cod really is kind of that third normal form these days, and that's going to eliminate transitive dependencies. With our logical design, we identify entities, we define attributes, we establish primary keys, and we define relationships, and then we, of course, normalize our design. So that is the goal of our logical design, which we've been working on. We have gone through this type of thing. We're going to go through this example, and after we get through the logical design in this video, we're going to go through the physical design in the next video. And this is where we have a student course unnormalized relation. This is in 0NF for unnormalized because we see that we have at least one repeating group of course ID. We have our student relation, and then of course we have the repeating group of that course. In order to make sure that we eliminate that repeating group, we take the primary key of our course relation that is the repeating group, and here we are not given any particular dependencies, but we can infer that the course name is going to go with the course ID. So in this case, if we're thinking about it, the course ID should be the primary key of that relation. And then we have our student relation, which the student ID would be the primary key of. And if we concatenate those two keys together, we should end up in first normal form, which I believe shows us on the next slide. So essentially, we represent that by underlying the two fields that are part of that primary key. So we have our student ID and our course ID, with our student course being the primary key. To move to second normal form, we need to remove any partial key dependencies. So right now our key is student ID and course ID combined. So if we have any dependencies that are just based off of student ID or just based off of course ID, we need to remove those from the relation and create new entities for those. In the case of the student ID, we have student name that is only dependent on that student ID. We have course ID and course name. The course name is only dependent on that course ID. If we look at the student ID and the course ID, that's going to be something that grade would be related to that combination. And if we look at the teacher name and the teacher email, at this point, we really don't have any particular information on how to factor in this. So we assume that they are going to go with the student ID, course ID combination. And if we go to the next slide, we should see that we have split out our student with student ID and student name, and course with course ID and course name, leaving us with student courses with the student ID, course ID, grade, teacher name, and teacher email. When we write this out, we also put in the functional dependencies that we've determined. So that's that student ID is now functionally determining our student name. Our course ID is functionally determining our course name. Our student ID and course ID are functionally determine the grade, the teacher name, and teacher email for the student courses. So we specify those up here. And we're just kind of going ahead and doing a shortcut where we're just using the combination of our student ID, comma, course name, and then just putting a comma separated list of all the fields that are showing in that relation. We also are going to not only note the primary keys, but we're also going to note the fact that we have foreign key associations between our student courses, which is going to point back to our student table. So our student table is going to be the parent table to the record that is in our student courses table. Similarly, we have our course ID that's going to point to the course. So the course is our parent that we are going to have a relationship of one-to-many between the course and the student courses. Same with the student, one-to-many between the student and the student courses. If we go to the next slide, we're going to be working on removing the transitive dependencies. And we only have really one transitive dependency left, and that is in our student courses. We have the teacher name and the teacher email. And this is something that we need to move into its own relation, and we need to leave one of the fields in the student courses. And the thing that we need to do here is, since we don't generally make primary keys out of name fields, they're really not something that we like to do because names could theoretically change. If somebody gets married, their name can change. If they decide that they just want to change their name, the name can change. And unfortunately, with primary keys, we never want the name to change. So therefore, when we have situations like this, we would go ahead and create a primary key using essentially an identity to do this. So this would be where we create a teacher ID. We would leave our teacher ID within the student courses, and then we would create a teacher entity, and that would be keyed by the teacher ID, and then it would contain the teacher name and the teacher email. So as we go to our third normal form, we see that we have our teacher ID pointing to our teacher name and teacher email on our functional dependency. We also see that we have this showing up here, and we have added the foreign key for our teacher ID to our new teacher table. Now that we have all of this information, this is essentially what we're going to use when we get into physical design. And we'll be looking at that in our next video. But before we do that, we kind of want to put together a rough entity diagram. We will transition from doing this rough entity diagram to using Oracle Data Modeler. With Oracle Data Modeler, we can do a logical design, then we can move our logical design into a relational model, which is going to give us an entity relation diagram that is more consistent with how we model our database entities. And we'll be working on this after we get through this particular set of videos this week. That will be for upcoming videos. But we're going to take a look at what the logical looks like when we generate it from within the Oracle Data Modeler. This is going to give us at least a little idea of how the relationships are. And if we go to our next slide, I believe is the logical design that we created with the Oracle Data Modeler. It has essentially the attributes that are in the entity relation. It's showing us the primary key of those relations. And for those things where we have a key that's based off of a relationship, it's going to be essentially defined when we get to the relational model. Here it's just showing that we're going to be getting our teacher ID, our course ID, and our student ID from the relationships with these other entities. Therefore, we only have the grade that's represented in that particular entity at this time before we transition to that relational model. But that's going to be our goal. So at this point, we have all the information based off of what we've done here to go through the physical design process and create our data dictionary language, which we use to create databases and also tables, indexes, sequences, constraints, etc. And that's where we're going next.